Hey, Mr. Snyder here. Today we're going to talk about exponents, but before we do, I want to do a quick review of multiplication because you have to understand multiplication in order to understand exponents, okay? So let's just start off with the number 7, okay? 7 by itself, fun number, awesome, sweet, lucky number 7. All right, now here's the deal. Say, for example, I wanted to go ahead and take 7 and add 7 to itself, okay? 7 plus 7 is 14, super exciting. And they say, for example, I want to add another 7 to it, and then add another 7 to it, okay? We can add these together, okay? Eventually, over a long period of time, when you're adding the same number over and over and over to itself, it gets kind of long, okay? And there's a lot of writing involved. Now, you have to remember, mathematicians, including myself, we're pretty lazy people, okay? So we like to look for ways to go ahead and take things that look kind of long and make it kind of like easier to write or a smaller version of that same expression, okay? So for example, if you look at 7 plus 7 plus 7 plus 7, another way we can write that is just by going ahead and saying 4 times 7, okay? 4 times 7 is going to get us the same thing. We didn't have to write as much, but it's the same kind of thing. Remember, when we're adding something to itself, especially the same term, we can go ahead and simplify that down by going ahead and changing the coefficient in front of that number, or just multiplying that number by however many copies we have of that thing. For example, if I went ahead and said, okay, I have 10, and I want to add 10 to itself, let's see here, 5 times, okay? So 10 plus 10 plus 10 plus 10, that's pretty boring. I could write that a little bit quicker by just going ahead and say 5 times 10, because what that means is I have 5 copies of the number 10. In terms of algebra, if I went ahead and said I have x plus x plus x, most people would simplify this down to be 3 times x. The reason being is there are 3 copies of x, and notice how we multiply 3 times x. So that's what multiplication is all about. It's just a quicker way of adding terms together or adding numbers, okay? So just remember that for a second, that principle. I'm going to clear the screen, and I want to talk about exponents now, okay? Exponents are the same exact concept as multiplication. So multiplication is to addition as exponents is to multiplication, or lengths of multiplication. For example, let's look at 7 again. This time I want to multiply 7 times 7 times 7, okay? I could write that out until my face turns blue. In fact, that's probably what it's going to turn if I keep going, so I'm going to stop doing it. I'm going to stop at 3. How could I write this, though, easier? Because, again, we're lazy and we don't want to write it all the way out, okay? Exponents do that for us. In fact, all we have to do is write down the base number, 7, and raise it to the 3rd power. This is, in fact, the same thing as saying 7 times 7 times 7, okay? Let's just look at this again. Say, for example, 5. I want to multiply 5 times 5 times 5 times 5, okay? This time I'm going to take 5 and I'm going to raise it to the 4th power, because what that exponent is telling me is that I have 5 multiplied by itself 4 times, okay? And that's, in fact, how, for the most part, exponents work. Let's just look at a quick algebra problem. X times x. How many copies of x do I have? 2. And I'm not adding them together, so I don't just write this as 2x, okay? I'm actually multiplying together, which means I have to use an exponent in this case. So x squared is a equivalent form of x times x, okay? So that's kind of, for the most part, very basic on what an exponent is, okay? So let's go ahead and do a couple of these exponent problems out, and let's see if we can figure out a couple more. Okay, so let's go ahead and say we have 4 squared. This is a pretty common math problem. 4 squared, first of all, let's turn it into a multiplication problem, because that's how we can do this in our head, okay? If we don't know exactly what 4 squared is, we could go ahead and break it down, because 4 squared is really just 4 times itself, okay? Or 4 multiplied by itself twice, okay? 4 times 4, that's going to give me 16, okay? Let's just go ahead and try another one out. Say, for example, I have negative 4 squared, okay? This time, though, instead of having 4 times 4, I'm going to create 2 copies of negative 4, and I'm going to link them together through multiplication. So I have negative 4 times negative 4. Remember, when we multiply negative times negative, we indeed get a positive. Now, here's a tricky one. If I went ahead and said negative 4 squared, I would go ahead and write down the following. Negative 4 squared. Now, the difference between negative 4 in parentheses and outside the parentheses is we have to think a little bit about how order of operations work, okay? Order of operations says we have to do our exponent first before we do any multiplication. So when you view negative 4 squared, technically you have to raise 4 to the power of 2. So technically you're just doing 4 squared and then multiplying it by this negative out front. Now if you don't see a number out front, pretty much we can assume that to be a negative 1, okay? Now 4 squared, we just did that earlier, that's 16 times that negative 1. Therefore, it is negative 16 as the answer, okay? This is a common problem because most people, what they'll do is they'll say negative 4 squared is just a positive 16 when it really isn't. If you're taking the term negative 4 and then squaring it like in the parentheses, that's when you can go ahead and say that the answer is positive because of the idea of order of operations, okay? So I just thought I'd put that out there because that's one common mistake people make all the time. Let's go ahead and try a couple other things that people run into problems with. For example, if I have a number raised to the 0 power, what I want you to remember is anything raised to the 0 power is just going to be equal to 1, okay? So that is the same idea as, like, say, for example, anything times 0 is 0, but this time I want you to remember anything raised to the 0 is just going to be a solid 1. So that could be 5 to the 0, it could be 1,000 to the 0, okay? It will always equal 1, okay? We'll talk a little bit more in class probably sometime why that is, but for the most part, that's something you just have to remember, okay? Let's just talk about exponents real quick with fractions, and then we'll end the day with 2 more problems, okay? So here we go. Let's go ahead and say 1/2, and we're going to raise that to the 2nd power, okay? Now, something squared, that means there's 2 copies of it, and it's going to be linked together with multiplication. So 1/2 squared is really the same thing as saying 1/2 times 1/2, okay? 1/2 times 1/2. Well, we're multiplying fractions again, so we're going to multiply across the top, and that's going to just give us a 1, and then multiply across the bottom, and that's just going to give us a solid 4. So 1/2 times 1/2 is really 1/4, okay? Let's just go ahead and try one more out. We have 3 halves here. This time I don't want to raise it to the 2nd power. Let's raise it to the 3rd power. Ooh-wee. Maximize. All right, let's go ahead. I don't know what maximize means. Let's just go ahead and cube this. What that means is we're going to link 3 of these copies of 3 over 2. So 3 over 2 times 3 over 2 times 3 over 2, and we're going to link that again together with multiplication. So let's multiply straight across the top. 3 times 3 times 3, which is going to be 27, okay? Because 3 times 3 is 9, and 9 times 3 is 27. And then let's look at 2 times 2 times 2. That's going to just be 2 times 2 is 4, times 2 is 8, okay? And that, for the most part, is the answer. Well, of course, you'd want to look to make sure that it is reduced, which it is. But that is how we could go ahead and even take fractions and raise them to certain exponent powers, okay? So, to make a long story short, what you have to remember is there's a couple key words here. There's the number on the bottom, which is the base. So say, for example, 5 here is my base, okay? Then you have an exponent, okay? So say, for example, squared is the exponent, okay? So when I'm referring to exponents, I have 2 terms that I want you to kind of remember. Base, which is the number on the bottom, and then the little guy up top is called the exponent, okay? And then the exponent is just telling you how many copies of the base you have, and again, we're linking those things together with multiplication. I need to learn how to talk. Anyway, that's it for now. See you later. Bye-bye.